Hello, welcome to my channel CNCR Science and Math Concept. Here we are doing the question which is based on the topic of simple harmonic motion. The question is, show that for a particle in linear simple harmonic motion, average kinetic energy over a period of oscillation equals the average potential energy over the same period. So here we know that the displacement of particle is given by y is equals to r sine omega t. Therefore, its velocity is rate of change of displacement, which is equals to r, differentiation of sine is cos omega t into differentiation of omega t. So we get velocity is equals to r omega cos omega t. Now kinetic energy, say Ek is equals to half mv square. We put the value of v, so half m r square omega square cos square omega t. So this is kinetic energy. Now we know that potential energy of particle having simple harmonic motion is given by half m omega square y square. We put the value of y, that is half m omega square r square sine square omega t. Now for one oscillation time period is t. So now we find out average kinetic energy and potential energy over a time period of t. So average kinetic energy, that is E kinetic average, will be over 1 upon t integration Ek dt from 0 to t. Now this is total integration Ek dt is total energy during the interval of time divided by total time will be equals to average kinetic energy. So that is equals to 1 upon t integration half m r square omega square cos square omega t dt from 0 to t. Now half is constant, m is constant, r is constant. So 1 upon 2 times t m r square omega square integration 0 to t cos square omega t dt. Now we know that cos square theta is equals to 1 plus cos 2 theta upon 2. So now we put this. So average kinetic energy will be m r square omega square upon 2 times t integration from 0 to t 1 plus cos 2 omega t whole divided by 2 dt. Again we take 2 outside. So this becomes m r square omega square upon 4t. Integration of 1 dt is t and integration of cos is sine 2 omega t, and in integration the differentiation of 2 omega t in the denominator, that is 2 omega from 0 to t. So further we solve this. This is equals to m r square omega square upon 4t. Now this is t minus 0 plus 1 upon 2 omega sine 2 omega is 2 pi by t into t minus sine 0. So this is kinetic energy average or Ek average is equals to m, this is capital T, this is also capital T, so mr square omega square upon 4t into t. T minus 0 is t. Sine it in sine 4 pi t by t gets cancelled. Sine 4 pi is 0, sine 0 is 0, so we are remaining with this. Now again t gets cancelled. So what is average kinetic energy? So average kinetic energy is equals to 1 by 4 m r square omega square. This is for kinetic energy. Now we do for potential energy. Average potential energy will be 1 upon t integration from 0 to t EP dt. Now what was EP? EP was equals to half m omega square r square sine square omega t. So this is equals to 1 upon t integration from 0 to t half m omega square r square sine square omega t dt. Now again 1 by t into half m r square omega square is constant outside, integration 0 to t sine square omega t dt. Now sine square omega t dt can be written as sine square omega t can be written as 1 minus cos 2 omega t divided by 2. Therefore, this is equals to m r square omega square upon 2t integration from 0 to t at 1 minus cos 2 omega t by 2 dt. Now take 2 common outside. So this will become m r square omega square upon 4t. Now integration of 1 dt is t from 0 to t minus integration of cos is sine 2 omega t by 2 omega from 0 to t. Now this is equals to m r square omega square upon 4t into t minus 0, that is t minus 0. In the above expression for kinetic energy we have solved already for sine 2 omega t by 2 omega. So therefore average potential energy is equals to, now again this t will get cancelled, so we are having 1 by 4 m r square omega square. This is the relation for potential energy, and we have already derived the relation for kinetic energy. That was also equals to 1 by 4 m r square omega square. Therefore we can say average kinetic energy over a given time period is equals to average potential energy. That is all for this question. Keep watching my other videos for more challenging questions and do subscribe my channel.